Good morning, boys and girls. Okay, let us look at the chapter 7 and try to finish it as soon as possible because we have not much time left. Okay, so that is electricity and magnetism. So, you must have seen a magnet, okay? You must have played with actually a magnet. Okay, but you must know that where there is electricity, there is also magnetic property simultaneously with it. So, uh, electricity is always with, it produces magnetism. And you must have seen attracted iron pieces with the magnet. Okay, so now the other properties of magnet we'll look at. So a magnet has attracting property. It attracts small pieces of iron, and it has two poles, north and south, at the end. Okay, both ends. One is north and one is south. And the magnetic force is maximum at the poles, minimum at the center of the magnet. Now, directive property. When you suspend a magnet, okay, tie it with a thread and suspend it freely in air, it aligns itself in north-south direction because Earth also has magnetic property. So it aligns with that property, okay? Now, attractive property. I've already explained. It has maximum strength at the ends, which are called poles, and it is almost zero at the center of the magnet. Okay. Now, what happens if you break a magnet? Suppose there is a magnet, it has two poles here. Now, if you break it from the middle, still both the pieces will become separate magnets. They have different poles now. Okay? So the same poles do not exist in a broken magnet. They have different poles now. North becomes here, and the south of this magnet becomes here. Okay? So if you keep on breaking, the poles, new poles are formed, and they become and behave like a separate magnet. Now the other property, like poles of the magnet repel each other. Suppose north and north brought together, so they repel each other, and if opposite poles like north and south brought together, they attract each other. And the force between the magnetic poles depends inversely upon the square of distance between them. That means inversely means it's the reciprocal of the square of the distance square. Okay. 1 upon d square, you can say. Now, to test a magnet, whether it's magnet or not, we bring together two magnets. If they attract each other, they can be, both of them can be magnets, or one of them can be magnet. But we cannot say both of them are magnets, because a magnet attracts an iron piece also, simple or non-magnetic iron piece also. But if they repel each other, you bring opposite poles, then it is sure that both of them are magnet. Okay, so repulsion is the surest test to test a magnet. Now, electromagnetism. What is electromagnetism? I've already uh, told you that electricity always is, if there is electricity, there is magnetism, but in a very small amount. That's why we cannot observe it. But if we uh, wrap a long piece of wire together, then those magnetic property of electricity becomes more, or the strength becomes more, then we can easily observe the magnetic property. Okay, so now those are called electromagnets, which are produced by using electricity. So two types of magnet are there. One is a bar shape or eye shape, you can say, and another is U-shaped or horseshoe type. Okay, here is a picture showing an eye-shaped electromagnet. Okay, a simple nail. Eye shape means a simple nail or a piece, rod of iron, and you bind a wire around it. Okay, many times, and you connect it to a battery. Then it behaves like a magnet. Like this, it is attracting nails and pins. Okay, strength of magnetic field of an electromagnet depends upon now three things. Okay, how much current is supplied. Okay, the strength of electric current, you can say. Then number of turns of wire. So how many times you are winding the wire around it. Okay, that depends number of turns. Then the material of core, what type of material you are using. Okay, so you have different materials, iron, cobalt and all. So it depends upon the material also. So we can increase the strength by increasing the current, increasing the number of turns of wire, and using a core of high permeability. Now, what are the uses of electromagnet? We use it in doorbells, okay, telephone, telegraph, and loudspeakers. You must have seen that. Okay, when a speaker becomes useless, children take out the magnet and play with it. Also, electric horns, tape recorders, motors, dynamo circuits. Okay, so many uses are there. And in industries also, a huge electromagnet is used to collect the waste iron particles in industries. Okay, the scrap, which is the waste material when some uh, construction goes on. So they collect it using a huge electromagnet. They just bring it towards it and it attracts all the scrap over there, spread over there. And then they stop the current and it just leaves those scraps into the particular place which is collected and reused again. Okay. For separating magnetic and non-magnetic, you must have studied in your earlier classes how to separate magnetic and non-magnetic materials using a magnet, because magnet attracts all the magnetic materials and non-magnetic remains behind. So that's how we separate. In hospitals also, doctors also use, when some iron particle gets into the eye of a person, especially where they are using grinders and hall. So where iron fabrication work is going on, there the workers usually, uh, when they do not use glasses on their eyes, they may get iron particles into their eyes, and in fact, that iron particle is so hot that it sticks into the eye, so it cannot come easily. So doctors use electromagnet which attracts that particle, and then it comes out of the eye. Okay, now uh, we can also use electromagnet to produce a permanent magnet, okay, making a permanent magnet. So by using a coil means uh, uh, wire wounded up, and it is hollow in between. So they put a bar, iron bar there, and it becomes a magnet after a process, okay, for keeping it very long. So you have seen here in the picture also, you can see they are collecting scrap from a scrap yard, okay, using this electromagnet. It's a very huge magnet. Now electric bell. Electric bell, you can see here in the picture, this is how electric magnet functions. Okay, so its construction is there. Electromagnet, this is the electromagnet here, you can see, and armature. Okay, here is the armature, soft iron armature. This is the soft iron armature. Then metal strip is there here. This is this metal strip. And hammer is here. This is the hammer. And this is gong. And you can see the contact screw is here. Okay. And battery is here, switch is here. So these are all the parts of electric bell. Now what happens when this switch is pushed? So it's the circuit gets connected here, these wires, and the current from the battery starts flowing in the circuit, and it comes here, and these iron pieces becomes electromagnet. So it becomes electromagnet, and the circuit is going like this. From here the current, it is coming through here and going here and here, and from here it's going here, and this is how the circuit is complete. So now what happens when we push the switch? So the circuit, this is joined. Okay, the current starts flowing, this becomes magnet, and this magnet attracts this soft iron, okay, or the iron armature, and it gets attracted towards it, and as a result this hammer hits the gong and the sound is produced. But simultaneously what happens when it gets attracted, it is separated from this contact screw and the circuit breaks. Okay, the current no more flows, and when no more current flows, it gets back to its position. Okay, the armature moves back to its position, again it touches, and again it becomes magnet, again it attracts, and so on it goes on, and the hammer hits again and the sound is produced of the electric bell. So that is the how electric bell works. Okay, now you go through the electric bell up to here, read it carefully. Okay, and other topics I'll explain in the next video and try to finish it. Okay, and you also keep searching for the exercises.